Hi, hello. Today we are going to see about another machine learning algorithm that is called support vector machine. It was called as shortly SVM. This algorithm is a supervised machine learning algorithm that can be used for both classification and for regression. The goal of this algorithm goal of SVM is to find a hyperplane that can separate a group of data in a n-dimensional space. A goal of this the SVM is to find a hyperplane that can separate data point in an n-dimensional space. Okay, we can see how this is happen. Let's take there is a two-dimensional vector space. Here there are two types of groups. Let's take two types of groups. Like here we having some groups, and let's take another group of data points that are present here. Our aim is to find a hyperplane that separate those data points. For example, these are this is first group and this one is second group. This first group having some similarity and this second group have some similarities. We need to find a hyperplane that can separate these two groups, so that we can easily classify whenever a new point is coming, whether that point belongs to this group or this group, by using this hyperplane. Normally this hyperplane is have in a straight line. This hyperplane will separate these two groups, and this line is called as hyperplane that separate the two kind of groups. And we need to find another two lines. That line is we need to find another lines that is parallel to this hyperplane. The two lines will touch the nearest point of each group. We can see that we can see here, this is the hyperplane. The nearest point of the first group from this hyperplane is this. This point is nearest to this hyperplane, so that this line is touches the point of this group, and another line is parallel to this hyperplane that will touch the other group of the point which are near to this hyperplane. Let's take this group as positive and take this point as negative. The hyperplane will separate these two groups, and another two lines are created that are parallel to this hyperplane. That lines will touch the nearest point of each group, and the distance between these two lines, the distance between the hyperplane and the positive nearest point is called as d plus, and the point that and the line which touches the negative group from hyperplane, the distance between the hyperplane and the negative line will called as, the distance will called as, we can indicate it as d minus. This d plus plus d minus, this overall distance is called as margin. In SVM, we need to understand there are totally 5 concepts are there. First one is, what is hyperplane, and next one is support vector, and other one is margin. And in SVM there are two types of SVM type. The first one is linear SVM, and other one is non-linear SVM. Okay, we already see about what is hyperplane. Hyperplane is a decision boundary line that separate each group in a data set in a n-dimensional vector space. And what is support vector? The support vector is the point which are near to the hyperplane in each group is called as support vector. Here in this positive group, this point is near to this line. This is called as support vector. These points are called support vector. And for creating this another line which touches the negative points, that points which are near to the hyperplane, these two points are touches these two points are near to this hyperplane. These points are also called as support vector. And then there is a margin. The margin is a distance between the line which are touches the each group each group, the distance between the first marginal line to second marginal line is this is called as margin. And there is another two type in SVM, and linear SVM and non-linear SVM. These points are separated by a hyperplane. This hyperplane is in a linear form. We find a hyperplane which are in a straight format, this hyperplane is in a form of linear, and this hyperplane linearly separate this each group. So this hyperplane is this hyperplane is linearly separate these points. So does this model is called as linear SVM model. Let's take another example. For example, there are two groups which are in this form, like in this form. There are two type of data which are in this form. We need to find a hyperplane that separate this each group. But how it is possible? Whenever we try to create a hyperplane, it always separate these data by these lines. We can separate this by any one of this line, but it's not perfectly separate these two groups. To do this, we use unkernel. By we can find a hyperplane that can separate this each group. We use some kernel technique. In this kernel technique, by using this kernel technique, that will convert the lower dimension to higher dimension. Whenever we getting a non-linear data, the SVM will convert that data into a low dimension data into higher dimension data, so that this SVM for this in this example we have two dimension. Whenever we applying a kernel to find a hyperplane which can separate this each group, we want to apply kernel technique. That kernel technique will convert this two-dimension space into three-dimensional space, and then it will plot the data like this. So whenever you plotting the data in this dimension, we can get data like this. We can see this in a 3D image. for SVM kernel technique for non-linear. We can see here, you can easily understand what I am trying to say. For example, this data is in a non-linear format. This data is in two-dimensional vector space. After applying kernel, this data is converted into three-dimensional vector space, so that we can easily draw or find a hyperplane which can easily separate these two groups. Like this, the SVM will classify the non-linear data by using this kernel technique. And we can see in-depth concept of kernel tricks. There are some types of kernel tricks like linear kernel, polynomial kernel, and radial basis function kernel, and we have another type is called sigmoid kernel. This the linear kernel will separate a data point linearly. For this data, the kernel will linearly separate these 2 points. This technique is called linear kernel technique, and other one is polynomial kernel technique. This polynomial kernel technique will whenever we have a more than one dimension, more than 2 dimension of data, by using polynomial kernel we can separate we can separate that kind of that types of groups, and we have a radial basis functions, or it can be called as Gaussian kernel. We can see here this nonlinear data is converted into 3 dimension. After that, we will find a hyperplane. This type of kernel is called as Gaussian kernel. And another one is sigmoid kernel. It behaves like a neural network with one hidden layer. Mostly the sigmoid kernel is not used for an SVM algorithm. It was so rare, so we can leave it. Okay. And this is an classification algorithm. We can to validate this model, we use basically we use to calculate the accuracy. We can use some matrices like accuracy or confusional matrix, or we can use F1 score to find whether the model is performing well or not. Yes, the biggest advantage of SVM is a powerful and versatile classification algorithm, especially especially it will perform well in high dimensional space. It can ability to it have a ability to handle linear and non-linear data. So that SVM is mostly used for classification problems. When compared to decision tree and any other algorithm, whenever we have a more number of dimension data, we can use SVM. It can for a classification problem, it can perform well. These all the things for today. We can see another algorithm tomorrow. Thank you.